Broadcasting from Boston, Massachusetts, the ARC Digital Transformation Viewpoints podcast is the only podcast dedicated to all things related to digital transformation in energy, industrial, and critical infrastructure applications. The podcast is the creation of the ARC Advisory Group Digital Transformation Practice. ARC advises leading companies on technology trends and market dynamics that affect their business. To engage further, please like and share our podcasts or reach out directly on Twitter at ARC_advisory, or please go to the website at www.arcweb.com.
Welcome to Industrial Systems Engineering in the New Era of AI, Episode 4. We've been really going through a journey of rediscovering the foundational challenges of our industry, all the way through to the rise of what ARC calls Industrial Data Fabric, and the domain-specific innovators and startups that are really driving a lot of the momentum. Now today we're going to take the next logical step in our conversation. First 3 episodes I talked to a long-time innovator in the industry, and today I'm going to talk to another. So today we're going to explore how all of that AI-ready data is going to really get activated. And I'm thrilled to welcome Vatsal Shah, co-founder and CEO of Litmus Automation, a company at the heart of this transition, to discuss the critical link between the data foundations we've been talking about and the new wave of reliable agentic AI. So welcome, Vatsal.
Absolutely. First of all, thanks a lot, Colin. Yeah, thank you for having me. And this is I'm a huge fan of everything that you do. And for my commute, I listen to your podcast all the time. So I'm really happy to be here. Thank you.
Great. Well, I'm glad to hear some people are listening to the conversations. I enjoy them, and I hope we're going to have a great conversation again today. So maybe let's start by the why, right? Let's ground this in reality. Before Litmus, you were an industrial automation engineer, I believe. And what specific frustrations on the plant floor integrating systems from, I don't know, Rockwell, Siemens, Yokogawa made you realize a new approach was needed?
Yeah, absolutely. So I did start my career in the industrial side, automation engineering side. The first job that I got, it was just an internship itself, was in a power plant. So as you can imagine, like power plants, they are probably as messy as you can imagine. Like they have a bunch of these old DCS systems and bunch of these old control systems. And I was always curious. It was a short internship. But the idea that I realized is everything that we have been doing, it was created like so many decades ago. And they kept on running on it until it hits the ground. That was my first exposure to control systems. That was my first exposure to all this DCS and HMI and SCADA system. And again, not even SCADA. It was like a bunch of these buttons on the panel. That's what we used to deal with. And then like after a little while, I got a job on industrial automation engineering side itself, doing the real stuff. And the idea was that the first day of my job, it was like, okay, introduction, here is your laptop. And what you're going to do is, here is your PID diagram. Take that PID diagram and put it on the SCADA screen. And here are the 5 different reference documents available. Just go ahead and figure it out. It's like fresh out of university, and they just throw you in there because this is the grunt work that you have to do. You do it. But that just opened up so many possibilities for me. How manufacturing operations were working. How to understand what they were doing, why they were doing it, why system integrators were suggesting this. Sometimes we were all lazy. Sometimes we were quite innovative. But that gave them the exposure that I was looking for. One of the biggest moments was early in my career, I was working on a whole lot of oil and gas, a couple of Russian oil and gas, Middle Eastern oil and gas, and a couple of food and beverage customers itself. The idea was there was not a single vendor on those facilities. They were greenfield, but there were Yokogawa systems, Siemens system, Omron systems, and we had to do with the Fisher-Rosemount. If you are ever in oil and gas, Honeywell and Fisher-Rosemount, their sensors, they are as ruggedized as possible. So all different protocols, all different things. And when we got the project as a SCADA interface, we used to develop Excel macro scripts to get data out of those and make it available to our system. 6 guys did it for 4 months because we had to reverse engineer the code that they were giving. And the first line that I wrote, it is in the napkin before starting the Litmus itself, was, what do we want to be? We want to be Google for industrial data. Make it searchable, make it awesome. I just found that note recently again, after like 9 years. That's, again, saw the problem that there is no one unified access, there is no one unified way to do something with the data. And how do we create that beautiful interface sitting in Silicon Valley? Like in the world where user experiences are driven by social media companies and user experience are driven by software as a service companies, how do I take all of this innovation and bring it to manufacturing world? That usually just suck. They suck for manufacturing interfaces, and everything that they have created, it just built with a specific mindset under consideration. So founded Litmus, dumb, naive, young, and jumped on it.
Yeah, I mean, if people are hearing me chuckling, I started off as a chemical engineer in process control in process investigations, and so you kind of stirred up some old memories.
Yeah.
As you were talking through that experience. So let's talk about your company. You champion Industrial DataOps. So how do you define that, and how does it differ from just collecting data or building a massive data lake in the cloud?
Yeah, absolutely. So, like I think the word changed over time, which is like industrial edge platform and industrial edge data platform, industrial data platform, industrial data ops platform. It's a flavor of the week.
Industrial IoT.
Industrial IoT, and like M2M was the first wave in 2015, and just IoT came in and everybody jumped on that bandwagon. For me, it doesn't make any difference. Like, all we have to understand is customers are looking for collecting data from where? Their existing assets. How do they collect that data? How do they contextualize it? How do they store it? How do they analyze it? How do they integrate it to the broader ecosystem of industrial or IT products, IT cloud ecosystems? How do you integrate all of those things, and how do you simplify that journey that might fit into one of the spectrum of like a product categories that everybody keeps on talking about? Data ops, data platform, foundational data platform. It just, for me, manufacturing data is better in the hands of company that can drive a whole lot of value. That might be cloud data fabric, as you are championing, as well as like cloud companies, AI companies, machine learning. They need this data. How do we bridge that in a way that they can readily consume? That's data ops for me. And I understand, originally in 2018, 17, nobody was talking about it. Cognite and few other companies, they started talking industrial data ops a lot. That was I think one of the initial companies to talk about it, to model. And then, of course, it picked up as a brand new category after that point onwards. But it just, again, how do you solve the problem matters.
Yeah, I think I don't really want to get into deep discussions around data platforms versus data fabrics, etc., right? Because I think to me, it's a label, right?
Yeah, it's a label.
I tend to use the term fabric because I don't think anyone has a platform that is comprehensive. So in most cases, people are having to weave together, right, multiple components. And so I prefer at least in my mind, I visualize a fabric being woven from multiple systems, right?
Exactly.
So I tend to use that as my personal visualization of what needs to happen. I also like to break down some of the traditional silos. So a lot of what I've been writing about is really the fact that OT, IT, ET, if you bring in the engineering and technology side of it, and data science actually have a lot of common interests, but they call them different things. They optimize for different things. They're coming from all have different preferences on their platforms, right?
Absolutely.
And so I tend to use the concept of a fabric just to get everyone to step back and say, all right, maybe we have to take a different approach. I think what everyone has in mind and why you reached out to me was this idea of context engineering that, I think Rick and I probably said context 30, 40, 50 times in those first 3 episodes without really, we did kind of sketch out what we meant by context, but I think you really want to take that a step further and talk about contextualizing data and where that needs to happen. So in my recent blog on context engineering, I kind of talked about the necessary evolution from prompt engineering to context engineering, which we'd kind of been talking about, but I hadn't quite put it in those terms. And so I think thank you for reaching out and kind of inspiring me to write that blog. But what I'd really like to understand is, how does you think about what is driving the market, I would argue today, from, and let's call it industrial data ops from now, for folks like you that do a really good job in that space, to take the next step and make that data contextualized for AI-ready consumption, wherever that may be, whether it's IT asking for it, it's being used by OT on the edge, or you've got data scientists that need some subset, and it may not even be real-time access, but need some context for some of that data that we tend to think we own as OT on the factory floor. So I'd love to get your ideas on what is this context engineering approach and how are you using it to shape what you're doing and your roadmap moving forward.
Absolutely, yeah. Now, happy to jump on it. So, let's think from a two different point of view. The point of view number one, which is evolution of AI systems on its own. If manufacturing and industrial doesn't exist, or manufacturing has nothing to do with AI is already evolving as of this moment. Which is, it started with prompt. I still remember my first prompt that I put on ChatGPT. I still have the screenshot of it. The idea was, you give some input and it is giving some output as a part of this generative AI element. The moment that got introduced, the chase for everybody else was I want my own relevant information out. Rather than you telling me what you know from 6 months ago or a year ago, I want the information in a way that I can use it right now and it's 100% relevant, and I don't want to keep on editing it myself. So the first generation of product was introduced as a RAG, which is, of course, like it goes back, make an enterprise call, it's going to get something out. The second generation opened up from RAG, and then MCP servers are opening up, which is much more like REST API extension on the top of the data itself. So the idea that evolved is, give me the response which is relevant to me rather than anything else. Again, nothing to do with manufacturing or industrial. It just context engineering evolved as understanding the data behind the answer that you're giving me. Now let's go back to the reality. If you go in a manufacturing site, like I was just in one of the largest tools manufacturer in North America. We use it. I have a bunch of that. Half of my garages is that product. Like I looked at it, and they had close to 35 CNC machines, and they had close to 100 SKUs of product that they were manufacturing for research, and close to 40 different assembly lines where they were making the exact same things again and again. Today they are making this batch of product. Tomorrow it might be something else. So let's take an example. Today they are making drill, and then there is an impact driver that they make. So Litmus Edge was already running on a big screen on the top of it, and now they are asked us, how would you introduce AI to solve this specific quality issue that we have? Then we went one step further. Okay, you're asking us the question, you want to use AI to solve it, not the visual inspection. And now you want to understand the specific element, which is impact driver are allowed to have this much width. Drills are not allowed to have this much width, or they should not have this much weight. So quality assurance system started asking for more data than Litmus Edge originally had, which is what you are manufacturing, why you are manufacturing. So before we do the prompt now, we have to feed with the context of what's going on in the plant floor itself. I'm manufacturing impact driver with 40 volt capacity, not 24 volt capacity. With 40 volt, I have a capacity of running it as 1,000 RPM. Your quality assurance needs to know this before it can flag it as a good product versus bad product. Brilliant. I was like, okay, this is what context engineering is built for. And then how do you collect that data? How do you model it? How do you contextualize with the correct information so AI doesn't give you dumb responses? Is all what context engineering is all about. Deterministic, I can't really tell that just yet. It's not deterministic, but it is very, very high accuracy if you do context engineering right.
Okay, so I think what I'm hearing from you is that you kind of saw this demand for, going beyond the simple prompt, Copilot, to you had to start, whether it was using RAG or prompt engineering in some form. You were providing additional context. That's kind of what the general AI market has been doing.
Okay.
In the world that you and I and anyone in industrial systems engineering operates, it's kind of a bit more complex than that, because understanding what is happening in a factory on a production line is very time dependent, right?
Yes.
Very dynamic.
Yeah.
And we don't have the luxury of the large language models having been trained on that data, right? And so in a lot of cases you're having to provide that context. And so it's a systems engineering approach that needs to not just provide context that we get from, let's say, a unified namespace. That's part of it.
Part of it, yeah.
But there's all this other dynamics, and you want to know what has happened before. You want to know, may need to use multiple techniques. It's certainly not something that you can expect to handle many of the use cases that we see with a single prompt. There's usually a lot more complexity than that. So am I framing this more or less correctly?
Spot on. Yeah, no, 100% spot on. So it's like as we understand it, if you look at a prompt, you want to solve some hard problem with that prompt. It might not be solving it because it doesn't have understanding of what's going on. So we created a framework internally at Litmus, which is around this context engineering itself, that we had this 50 different customers trying different. So we created this AI workflow engine. We introduced it at a Prove It event last year, and it was built around unified namespace. So we have data from unified namespace. How do you do the prompt chaining to get the result that you want? And then we started seeing that customers were trying, customers were happy with it, but they kept on asking, how can I feed this one more piece of information to this prompt that you're not letting me do right now? And that was pretty eye-opening. So we created this context engineering is a square box with 4 different things that you have to take care of. It did start with what you want to get it done. That might be user prompt, that might be system prompts that you normally enter for any AI activity, which is write a blog for me, create the podcast for me, or create this social media post for me. That's a system prompt, user prompt, and then system prompt, which is attached with that. Then you go one step further, which is what type of memory do they have access to? This is the beautiful thing. We use the word memory in a generic way, but on this assembly line, we just manufactured 500 pieces of impact drivers. That's the memory. How do you enable that memory so it knows what's going on live right now? What's the work order that you are executing? How many workers are working? How many rejections happen? Like a very small list of key values available from unified namespace or available from database doesn't really make any difference. But the idea is that the second thing is memory that you have to attach. So it knows